Hi, we are going to discuss today solving compound inequalities with AND. These types of inequalities are usually more challenging than the ones that have OR. There are a lot of different situations here. The main thing is when you solve these are called conjunctions, and the inequalities, out of two inequalities, they're connected with AND. It is required that both inequalities are true, and this is where it's going to be true. So let's consider this first example. X plus 3 is greater than 1, and then this. So we solve it for x. This one gives us x is greater than negative 2. This one, when we solve it, is x is less than or equal to 5. And connected with AND. So each inequality individually. X is greater than negative 2, open at negative 2, we're going to shade to the right. And then x is less than or equal to 5, closed circle, and we're going to shade to the left. But here's the important thing that you need to understand about this. When you are here to the right of 5, this inequality will be true, but this one will be false. When you are on the left of negative 2, this inequality will be true, but this one will be false. So the only part of the number line where they're both true is going to be between negative 2 and 5. And that's exactly what we have here. Okay, so this is the part that you are going to leave shaded, and everything else is going to be erased. I recommend when you do this, you use a pencil, because with these types of problems it is very common that parts of the number line that you shaded have to be erased. This is what we have. This is the solution as using interval notation, open at negative 2 and closed at 5. So from negative 2 to 5. So the main thing that you need to understand from this is conjunction is going to be true in the part where the shaded region overlap. And this is the solution. That's exactly what happened here. Let's take a look at our next example. These two inequalities, so we solve this one's going to be x is less than or equal to negative 2. This is going to give you x is less than 3. So you can probably see that they go in the same direction, but you know, we are first going to graph both inequalities individually. Less than or equal to negative 2, less than 3. Okay. So the question is, where do they overlap? Here's the thing. Over here, to the right of 3, none of the inequalities is going to be true. Between negative 2 and positive 3, only this inequality will be true, but not that one. So the part where they're both true is going to be to the left of negative 2, with negative 2 included. So we erase that part as we can't use it. And that's the part that's going to be remaining. So it's going to be from negative infinity to negative 2 included. Okay. Solve this next one. So there's a couple of steps involved. This one's going to give you 2x is less than 4, which is x is less than 2. This one's going to be, we have to divide by negative 2, so we have to flip the sign. X is going to be greater than or equal to 3. So let's grab this. 2 less than 2. 3 closed greater than 3. Here's the problem here. You have nothing, you have no overlap, because that's what we want for inequalities containing, for compound inequalities containing AND. So since there is no overlap, you have no part of the number line where both inequalities will be true, and hence the answer is going to be no solution here. And when you deal with the graph, you can't graph anything on the number line, because there is no part of the number line where any valid values are going to be. Okay? Let's take a look at a couple more examples. So here we're going to get 2x is greater than or equal to negative 8, which gives us x is greater than or equal to negative 4. This one's going to give us negative x is greater than or equal to 5, and it's going to be x is less than or equal to negative 5. Right? So greater than or equal to negative 4, less than or equal to negative 5. Again, we have the same problem. They are going in the opposite directions and there will be no overlap. So here's -4, closed. And here is going to be -5, also closed, but it's irrelevant. You have no overlap, so there's going to be no solution here because we do not have any overlap, and you cannot leave anything shaded when you deal with the graph. Okay, because you must have something overlapping. And example 5. So we have these two inequalities. 2x is less than negative. No, I'm sorry. 2x is less than 8, which gives you x is less than 4. And here, when we divide by -3, we flip the sign. It's going to be x is greater than 4. So you have to be very careful with these types of inequalities, because yes, you have 4, but it's open. For one inequality, you go to the right. For the other inequality, you go to the left. But the two inequalities do not overlap. The boundary point 4 is not actually a common point, it's open. So because of that, you still do not have any solution here, and that's exactly what we're going to write. And again, we're going to have to erase that. The only way this particular situation here might have had a solution if these were both greater, like this one was less than or equal to and this one was greater than or equal to, but then you would have had only one value, which would have been 4, but with this way it's not going to work. So hope this helps.